Welcome friends, I am Tanmoy. So you all are welcome in my channel Chemistry the Mystery of Molecules. Today I am going to explain the Wittig reaction and effect of ionic salt and one equivalent of additional base. So before this video I suggest you please read two of my video. One is basic about Wittig reaction, second is mechanism. If you understand this mechanism with stereochemistry, then it will be very easier for you to understand, otherwise you will be confused. So first see that video, after that it will be better if you see this video. Actually this Wittig reaction we can consider that this is a Ionic, means RCH PPH3, this is a minus plus, which could be written in this way that this can come here and stabilize. Okay, so in this way Wittig reagent we can write, and this Wittig reagent it's a carbon ion, so reacts with this carbonyl group and produces ultimately alkene. So what happens? Addition of 1 unit of salt like lithium bromide and 1 unit of very strong base like this phenyl lithium, okay, produces selectively not alkene, trans alkene. What do I mean? If it produces, then it will be R, this R. If we let's say R1, this is R1, trans alkene. The question I told in previous video that stable Wittig produces trans alkene, unstable Wittig produces cis alkene. The trick to remember is that stable Wittig produces stable alkene. Stable alkene is trans alkene, stable produces stable, unstable produces unstable, and cis is little less stable, but you can, for mnemonic device, you can consider it as an unstable. Okay. So the question is, what is the role of this salt? So to get the details, first we have to understand what happens after this reaction. This carbon ion attacks and opens up this ring, means actually what happens, this RCH reacts with this R1, this CHO, reactor reaction, it produces O minus, this carbon ion, and this O minus, this should be PPH, this should be added with PPH3. So it produces this triphenyl phosphine adduct. Okay, and I have explained that since the bond energy of phosphorus oxygen is higher and stable, that's why these will attack here and 4-member ring will be converted. This is called oxytene. Okay, PPH3, and here is R and here is R1. This is oxytene. So this oxytene intermediate undergo ring opening in presence of salt like lithium plus. This is the main important step. Okay, so in presence of lithium plus, it produces this ring opening happens, and it produces this O minus and PPH3 plus, and here this is R, this is R1 and this is R. Okay, fine. So what happens? Lithium coordinates with this oxygen, and that is the reason that this oxygen forms this B10 intermediate. So such type of epoxide ring opening you have observed when epoxide is reacted with triphenyl phosphine, which results in this B10 intermediate. So this, and right now you can see this PPH3 containing this, there is one proton, this proton. Okay, and this proton could be abstracted by the added 1 extra unit of base. So this proton is abstracted by this phenyl lithium, and another one anion is generated. What? This PPH3 minus I. This anion generated, and this lithium is still coordinated. So this is R1. So this generated anion. Now right now you can see here is one hydrogen, one phosphorus, 2. Previously it was an sp3 center. It was also an sp3 center. So stereochemistry was written here. But right now this is an sp2 hybridized center, this carbanion. So since this carbanion is sp2 hybridized, so it is sp2 hybridized, so it's planar. So right now no restriction of geometry is observed. So consequently what happened? This became right now planar, and it will take another 1 unit of proton, okay, and that will be trans. For example, if this hydrogen is above and this R is in below, then definitely it will undergo a stable conformation. For what does it mean? Means it is, since it is in below, so it will definitely come to above, front side, because in this way the energy of activation will be, means it will be, so its energy will be less, it will be relatively more stable. So this is R1 and this is H, and another hydrogen that is in backside. So after that, this PPH3 plus and this O minus will react together, means they will form the bond again, this, and after formation of this bond it will break, sorry, I made mistake. So this will go, this will come, and it will produce this. It's a hydrogen and R, same side R, and so it's a trans alkene actually. So this is R1, this is R2. So rest of hydrogen. So what is the role of this lithium? First one, it breaks the ring to form this oxygen, betaine intermediate. First role. Second role is that abstraction of this proton. So abstraction of this proton will produce a planar sp2 hybridized carbanion, and that carbanion will take preferred geometry. Means since it will never allow the protonation such that these both are grouped in same condition, and it will exclusively result in this anti-conformation which will produce the trans alkene. So the first of all, this is to open the ring. Second of all, abstract the proton. Third, a protonation will occur to this anti. So in this way, Wittig reagent, using Wittig reagent, irrespective of stable or unstable, we can produce trans. Because unstable produces cis, that is difficult. So if we need to unstable, use the unstable Wittig reagent with aldehyde, then we will use this salt. Because in case of stable, it is not essential to use, because that will ultimately result in trans. So this is the strategy to get selectively this trans product. Okay. So this is the end of the lecture. If you like my teaching, please give a like and subscribe my channel Chemistry the Mystery of Molecule, and please share this video among your friends such that many people could be benefited from my effort. And finally, please press the bell icon to get the notification of every single video I upload. So see you in my next video.